All right, in this lesson, we're going to be reasoning with algebra. So we're going to start looking at two-column proofs and how they apply to geometry. And with this, we have to use deductive reasoning, and that law of detachment comes up a whole lot when we are writing proofs. So we're going to start out by looking at the algebraic properties. So a lot of our properties of equality come into play here. So these are things that you looked at in algebra, and we're going to apply those into our intro to two-column proofs. So the properties of equality with our operations, the addition property of equality says that if A and B are the same, then you can add the same number to both sides. So if you're adding the same thing to both sides, then it'll stay equal. The subtraction property of equality says that you are subtracting the same things from both sides. The multiplication property of equality says you are multiplying the same thing on both sides. And the division property of equality says you're dividing by the same thing on both sides. So here we have examples of each one and how they apply to solving equations. So if x minus 2 equals 3, then whenever I add 2 to both sides, it's going to stay the same. Subtracting 4, multiplying by 2, dividing by 4. So all of those are used when we are solving equations. So the reflexive property says that a value is always equal to itself. So 7 equals 7. The symmetric property says that if A equals B, then you can change the order to B equals A. We use that a lot if we're trying to flip something around to make the variable come first. The transitive property is the algebraic form of the law of syllogism. So it says that if A is equal to B and B is equal to C, then A is equal to C. So here you have a repeated part. So in this example, 8 plus 4 is equal to 3 plus 9, and 3 plus 9 is equal to 12. So we can say that 4 plus 8 is also equal to 12 based on the things that we know. All right, our next one is the substitution property, which says that if two things are equal, then we can replace one with the other. So if x is equal to 7, then 2x is going to equal 2 times 7. So we replace the x with the 7. And the distributive property says that you can distribute over parentheses in addition or subtraction. So if A is multiplied by the quantity A plus B, then it multiplies to both parts. So all of these go into solving equations, and we're just going to name each one. So when you are looking at a two-column proof, the two columns in this are the statements, which go on the left, which here is going to be the solving of the equation. And then on the right, we're going to put a reason for each step. So in a proof, you will always start with what they give you. So here it was given to us that 3x plus 12 equals 8x minus 18. So whatever is given to you is always going to be your first statement. And your first reason is always going to be a given. So anytime you start a proof, you can get that first step automatically because the equation that they gave us goes in the first statement. And the first reason is given because it was given to me in the question. Then you'll notice that some of the work part has been taken out in this two-column proof. So when you're thinking about a two-column proof, each time you're starting with an if. So if 3x plus 12 equals 8x plus 18, and the next step is thought of as like your then statement. So it's like a conditional statement, and we have to know why. So if 3x plus 12 equals 8x minus 18, then 3x plus 30 equals 8x, and over here in the reasons is going to be the why is that true. So the work doesn't really show up in a two-column proof, but it's happening in the background. So we have to figure out what's happening between each step. So if I look from my if statement to my then statement, what I see happened was that we added 18 to both sides. So even though that's not a statement in my proof, that's telling me why I got to where I was going. So adding 18 to both sides, if I look at my properties up here, adding the same thing to both sides is the addition property of equality. So that's going to go in the reason. So the addition property of equality, I'm going to shorten that with my equal sign. So in algebra, we focus on showing our work, and in geometry, we focus on telling why we're able to do that work. So this actual step in between here does not show up in my proof. So once I have that, I'm going to move down to my next statement. So if 3x plus 30 equals 8x, then 30 equals 5x. So to figure out the reason that I was able to go from step 2 to step 3, I have to think about the work that was done. So I'm going to put this back up here in blue just so that we can keep track of what we've done. And then I'm going to change colors. So looking at step 2 and then at step 3, 3x was subtracted. And it was subtracted from both sides. So anytime you are subtracting the same thing from both sides, that is the subtraction property of equality. So the reason I was able to get from step 2 to step 3 was because of the subtraction property of equality. So our reasons over here are explaining that step that we took. So subtracting the same thing from both sides is the subtraction property of equality. So now I'm going to move my if-then down another level. So if 30 equals 5x, then 6 equals x. So again, we have to figure out what work happened between those two steps. So to get from step 3 to step 4, both sides of that equation were divided by 5. So 30 divided by 5 is 6. 5x divided by 5 is x. Dividing the same thing from both sides is called the division property of equality. All right, so once we have that, we're going to move our conditional statement part down another level. So if 6 equals x, then x equals 6. So what happened here was that those things, our x moved to the front and our 6 moved to the back, so they just kind of switched places. So we have to think about which property tells us that we can switch the order around the equal sign. So looking up here, if a equals b, then b equals a. So if 6 equals x, then x equals 6. That is possible because of the symmetric property. So that is what I would put as my reason for this last step. So in algebra, it is like the first or second unit, but you are using these properties and you are getting ready to start writing proofs by telling a reason for each step. You just did not have this format yet of this 2-column proof. So sometimes we're going to have to solve the equation on our own. That one gave us all of the steps, and we were able to fill in the why by thinking about what happened between each step. So now we're going to do, this is a your turn question, and this will be on your Google form. So if you follow along and write this down, you will have the answers to that first part of the Google form. All right, so this one says if 4, and then in parentheses the quantity x minus 2, so 4 times the quantity x minus 2 equals 6x plus 14. So we have to think about this first statement, and this was in the original problem, so your first reason should always be given. So as we work down through here, we're going to think about what we would do to solve this equation. So what we do is part of our reason. Our next statement is going to be the result. So we aren't really showing our work because that's part of our reason. So I will show my work so that I can get those things. So if I see parentheses in an equation, the first thing I'm going to do is to multiply that number outside into the parentheses. So if 4 times the quantity x minus 2, then now I can simplify that down. So 4 times the quantity x minus 2 is going to be 4x minus 8. I multiply both parts. So the other part of the equation doesn't really change. And so the thing that I used there whenever I'm multiplying into parentheses, that is where, so I ended up with this statement, that is because I used the distributive property. So the work that I did in between there was the distributive property. All right, so now let's look at where we can go from here. So remember that the work that we would show is telling me what reason I'm going to give. So when I'm solving equations and I have a variable and a constant on both sides, I like to move the variable with the smaller coefficient first. That way I'm dealing with positive coefficients. So the next thing I'm going to do is I'm going to subtract 4x from both sides. So if I'm subtracting the same thing from both sides, that tells me what my reason is going to be. So that's called the subtraction property of equality. So the result that I get from subtracting 4x from both sides is my next statement, statement number 3. So once I do that, I'm going to have negative 8 equals 2x plus 14. So if I keep with kind of leaving things the color that they were, the negative 8 didn't change. The equal sign didn't change, but 6x minus 4x is 2x, and then the plus 14 hasn't changed. So kind of color coding, the 2x came from the subtraction property of equality. So now looking at where I am, I need to figure out what I can do next. So my goal is going to be to get the x by itself. So the next thing I'm going to do is subtract 14 from both sides. So subtracting something from both sides is the subtraction property of equality. So this reason goes along with what we have done. Then I'm going to look at my result. So it's kind of like after we draw our equal sign, what do we have left? So negative 8 minus 14 is going to be negative 22. And I'm not really changing my equal sign. I didn't do anything to the 2x this time, but I did get rid of that 14 that was added to it. So now I have negative 2x equals 22. So I need to look at what I can do from here. So to solve this equation, I would divide both sides by 2. So doing something to both sides is a property of equality. This is the division property of equality. All right, so then I'm going to look at my result. So the result of negative 22 divided by 2 is negative 11. The result of 2x divided by 2 is x. So now I have this statement. So if negative 11 equals x, and for this particular topic, we want the variable to come first. So I want my last statement to be an x equals statement. So if negative 11 equals x, then x equals negative 11. In that step, we just change the order of the answer, what came first, and that was called the symmetric property. So here we used our symmetric property last. All right, so that is the first check your progress problem. So make sure that you have that one saved in your memory so that you can skip through all of those multiple choice questions.